Every challenge question, part 47. This is Core Pure 2, chapter 4, which is on the volumes of revolution. So, okay, we've got a function here, which is defined to be sine of x, and we've got this line here. We want to rotate this function around this line, not around the x-axis or the y-axis, but around this line and find the volume found. Well, that's actually not too bad, because all we have to do is first we need to find the coordinates of intersection here. So when does sine of x equal 1 over root 2? Well, hopefully you just know off the top of your head that's at pi over 4 and 3 pi over 4. If you don't, I guess a calculator could help you with that. And then, okay, I don't know how to do a volume revolution around anything other than the x-axis or the y-axis. So what I'm going to do here is I'm going to shift this graph down by 1 over root 2, the sine graph, and therefore it will just look like this up to the x-axis, and then I can just rotate it around the x-axis. So let's actually move the graph down, shift it down by 1 over root 2, and then we can just do our standard pi times the integral of y squared, y being sine of x minus 1 over root 2, because that's how far I've moved it down, dx. And then, of course, between the bounds that we found before. And I think this is all I have to do. Just shift the graph down and then rotate around the x-axis. I think that's basically a good plan. Expand this out then. Happy to integrate these things over here. Not so happy to integrate this. There's a bunch of ways you could do it, but using the double angle formula is probably the easiest one. So I just Googled the double angle formulas and rearranged it in my head and got this. And then, of course, I could integrate all of these things very happily. I'll end up with half plus half is 1, so that integrates to x. And then this integrates to this, and this integrates to this. Sine integrates to minus cos, of course. Good practice here of putting in exact values if you want to. Sine of 6 pi over 2 is minus 1, so that makes it plus a quarter. And cos of 3 pi over 4 is, what is that? Doing this live is always risky. It's minus 1 over root 2, right? Which cancels with the root 2 just to make a minus 1. And then you can put in pi over 4. Sine of pi over 2 is just positive 1, so that just makes a quarter, or minus a quarter as it already is. And then cos of pi over 4 is just 1 over root 2, so that cancels, get a 1. And then this stuff goes together, so it makes a pi over 2 here. These two things make a half, and those make a minus 2, so it's minus 1.5. And then factorize out the half, and you end up with what they wanted you to get. So quite a nice little question there. Next one's really interesting. I've never seen a question like this before. They're asking me to find the, given parametric things, that's fine, I know how to do this parametrically, but they're asking me to find the volume when I spin it around the line y equals x, this diagonal line here. Now, like I said in the previous question, I have no idea how to do that. I only know how to spin things around the x-axis and the y-axis. So how do I do this? Well, this is why they've given it in parametric equations, is because what we can do is we can just rotate this entire picture around 45 degrees. So here's the matrix for rotation, anti-clockwise. So if I want to get it down to the x-axis, I need to rotate this minus 45 degrees to get it to go clockwise. So I'm going to rotate this entire picture, and I'll show you how to do that in a second, minus 45 degrees. Cos of minus 45 is just 1 over root 2. This is obviously 1 over root 2 as well. Sine of minus 45 is minus 1 over root 2, so that makes a positive there and a minus here. And then I factorize out the 1 over root 2 to make this the matrix of rotation, to make this entire picture swivel down and give me an area above the x-axis. So, okay, that's the first step. The second step needs to be finding my bounds for integration here. So when does this curve here equal this curve here? Well, it's when x equals y here. So that's when t squared equals 2t over here. In fact, I've done some more things here. Okay, so that's not what I've done first. What I've done first is just times that by the x and the y. And this is why parametric is good, because if I replace that with the x and that with the y there, I can just find new parametric equations here and say my x needs to be 1 over root 2 t squared plus 2t, and my y needs to be the same, but with a minus there. Okay, now I'm doing what I said here, which is set these two things equal to each other to find when this curve is on the line y equals x, which happens, of course, at either t is 0 or t is 2. And so t is 2 is it doesn't make a difference when I rotate this. T is 2 is still when the y coordinate is going to be 0, and that's therefore when I'm on the x-axis. That's going to be good, so t is 2 is what I need. So I'm going to do the integral between 0 and 2, with a pi on the outside, of course, of y squared dx. But dx can be cleverly written as dx by dt. And now I'm going to do this whole thing in terms of t. So dx by dt, differentiating this is just this. Y squared is going to be a half into this thing squared, which is just this. I've just expanded our bracket, so it's this times itself, which is plus t to the 4, and so on. You get this. So that goes in here, and this goes in there. And now I think I can just integrate this. I factored out a half root 2, I guess. There is what I did. And then I got ready to expand these things, which I did here. Yeah, I think that's just me expanding it. So that's what, 2t to the 5, and then plus t to the 4 minus 8t to the 3 makes, sorry, t to the 4 makes minus 6t to the 4. And then the t to the 3s must all cancel. Those cancel with those. Yeah, they do. Fine. And then you get this at the end. Factorize out a 2 to cancel with this 2, I guess, which is happy because there's no 2 on the generator here, which is good. And then I think I can just integrate. I think it's all straightforward from here. Put the 2's in. I couldn't be bothered to do this without calculator, so I just typed it into 1, and I magically got this here, which is the answer. Really interesting question. Haven't seen anything like that before, which was great. Like it when they do that. I'll see you next time.